Hey everyone, it's Matt here with Nightrun Studio, and in our last video we got things set up so that we could save simple data, like our player's position and health. That said, there's a lot more complex data going on here, like whether we've defeated enemies, opened chests, or collected items. And so in this video, we're going to show how to save those. Heads up, this one is a little specific to our Metroidvania, as we will be using the world state we set up earlier in the series in order to persist data when we move between scenes. Alright, that's where we're headed in this video. Let's get started. Alright, so first things first, let's open up our world state script, which is where we're currently saving data like defeated enemies, opened chests, and collected loot whenever we move back and forth between scenes. Currently these are saved in hash sets, which work like lists of strings, except that they're a little more memory efficient. Now if we go to our save data, we're going to want to create a place to save this data in memory between sessions. You cannot serialize a hash set, and so we're going to use lists here instead. So I'm going to go ahead and create a public list of strings. The first one will be for our enemies defeated, and I'll just initialize it as a new empty list. Now it doesn't like the list reference there, so we'll just have to come up top and make sure that we are using system.collections.generic. We'll have another public list of strings for our opened chests. We'll initialize that one as a new list, and finally make a last list of strings for our collected loot, and again, initializing it as an empty list. At this point, we can go back to our world state, and as we did for our player persisted script, we're going to make this one inherit from iData persistence. I'm going to take advantage of my IDE by right-clicking, going to show context actions here, and just implementing the interface. You might have to write these out for yourself if yours doesn't do that. This will just create these two empty methods for us for saving and loading data. Now before we can use those, we are going to need a reference to our save manager. So I'll just create a private save manager reference. Next, we'll add back our start method. Here we'll just fill that save manager reference by asking the service locator to get us a save manager. We'll then go to the save manager and tell it that we want to register this script. If we pop into save manager, you'll remember that we have this register method here, which just allows scripts like the world state or player persistence to register themselves. And then whenever we call save or load game, the script then just lets all of those objects know that it's time to run their save or load data methods. All right, with that done, let's head back to world state as we're ready to actually have something happen. So whenever we call save data, we're just going to talk to that save data that got passed in from the save manager and tell it that its defeated enemies should be equal to a new list of strings, and here we'll just pass along our hash set of defeated enemies, transferring the data from world state into memory. We'll then do the exact same thing for other hash sets. We'll get our save data for open chests and make it a new list of strings, passing along our open chest hash set. And finally, for save data's collected loot, we'll also pass along the string here in world state, which has our hash set of collected loot. We'll then do the repetitive task of doing the same thing in inverse. So whenever we load data, we'll just get this hash set for defeated enemies, and we'll create a new hash set for it, and we'll just load in the saved data's value for defeated enemies. We'll do the exact same thing for open chests. And then do the exact same thing again for collected loot. Now in a perfect world, this would all work great, except that there's a problem. If you look in the save manager, you can see that we don't actually run load after initialize until 1 frame after start. However, if we go into enemy, we can see that in start, it's trying to access world state in order to get its data before world state has had a chance to actually load that data. So then, our save manager registers in awake. Then, in start, we get our persistence objects like player persistence and world state registering. A frame later, the save manager calls load and gives them their data. Now what we need is some sort of an event that can be sent out so that objects like enemy, chest, and loot know the data's ready and can actually act on it. So then, let's pop into save manager and make that event. This is going to be a public static event, and in order for our code to read that, we're going to need to add that we are using system. Now the event type here is an action, and it's just going to fire a message, and we're going to call this one on save data loaded. From here, all we need to do is come down to our load game method and make sure that after we've sent out the data to all the persistent objects, we then send out a message saying that our saved data has been loaded. We'll put a question mark just to make sure that there's actually somebody listening. And if there is, we'll invoke it saying, okay guys, it's time to actually do your thing. The data's ready. Now this does mean we'll have to do a little restructuring in our other scripts. So if we come into enemy here, in start, we still want to get our world state right away in start, but we don't want to load its data and decide whether the enemy should exist until the data is ready. So this is where we'll just go to our save manager and get that on save data loaded and subscribe to it so that as soon as it's called, we'll initialize this script from the save. Now, regardless of whether we're loading save data or not, we want to make sure to initialize our state machine. So we'll copy and paste that line in here. Then we can come down below, and first of all, since we're subscribing to on save data loaded, we want to make sure that when we destroy this object or the enemy gets defeated, that we also unsubscribe. Now that we've got our subscriptions all figured out, we can actually write this method to initialize from save. Here we can copy and paste our if statement, as since all of our saving is initialized, we're finally ready to check the new world state to see if this enemy should destroy itself or not. Now at this point we can get rid of the return statement, as there's only this one line of logic here, and we actually don't need these curly brackets either, so I'll just get rid of them to keep things nice and concise. With that done, we've now delayed the world state check to allow our save to load, but we've also prepared things so that our state machine will be initialized if there's no save data. Back in Unity, I'll just set my enemy to just 1 health so that we can test more quickly. We'll hit play. When I get in the game, you'll see that our old save data loaded. I can defeat this enemy. Now then, when I stop, restart the game, you'll notice that the enemy is no longer there. There was a little flicker, but don't worry about that. That's the sort of thing we cover up with a loading fade in later on. Now that we've got our enemies working, we essentially want to use the exact same pattern for our chests and our collected loot as well. So in chest, let's come on down to our start method. Once again, we'll just separate off this if statement that checks the world state, and we'll set it in its own private void on initialize from save method. We'll make sure all of our curly brackets line up, head back to start and close that method with a close bracket. And then at this point we can do our subscription. So we'll tell our save manager that we'd like to subscribe to the on save data loaded, and that when that event is called, we run our on initialize from save method. And then again in on destroy, we'll make sure to unsubscribe from that event. Now you could test that right away, but I'm just going to go into loot and quickly set it up. So let's head into start. We'll separate off the if statement by closing off the start method, and then we'll give it its own private void on initialize from save method. Back in our start method then, we'll once again tell the save manager that we want to subscribe to on save data loaded, and that at that time we'll run our on initialize method. Finally, we can use on destroy to make sure that we unsubscribe so that once this loot's no longer in the game, it's not still trying to listen to event calls. Now in order to do a true proper test, I'm just going to delete the old save file, then we'll hit play. I'll make sure that I destroy the enemy, loot all of my chests, and then let's head over onto this ledge here. Now then, when I stop and hit play again, you can see that it's working quite nicely. The enemy's gone, the chests are looted, and my player was in the right position. Alright, now there's one little problem left, and that's just that when we leave the scene, and here my parallax is acting up a bit, and come on back, you can see that our save data is no longer loading. And that's just because our initialize from save only gets run once when the game begins. That's a problem. To fix it, what we're going to want to do is go into our scripts like enemy, and just make sure that after we subscribe to initialize from save, we call it anyways. That's because the initialize from save is what sets up our scene and talks to the world state. So whether we have save data or not, we want to make sure that we always call initialize in order to set up our scene. If we're just loading a new game from a save file, it will overwrite that later when this event is fired, and if not, it'll just use whatever is currently held in world state to set up the scene. We can then copy that line, head on over to chests, and paste that in, and then do the exact same thing for our loot. With that done, we now have save data that persists within the scene, but also allows us to leave a scene during gameplay, come on back, and have the changes persist. Alright, that's working pretty nicely, though we do still have work to do. In the next video, we'll show how to persist things like our stats and player progression. We'll show how to handle saving which scene we're currently in, and finally we'll show how to create multiple save files and load those from your menu. Hope to see you in those videos. Until then, this is Matt with Nightrun Studio. Cheers.